How often do you use a like button? They are in so many applications nowadays, and they use user feedback to provide better recommendations. But what happens when a user lies in their feedback? I will show you how users trying to reach their goal earlier may be not truthful in their feedback. Hi, I am Fabio Colella. I am a master student in machine learning at Aalto University. And today I will show you how human strategic steering improves performance of interactive optimization. You can also check our presentation website with further information, a demo, and our repository. We studied the setting of interactive optimization because it has many relevant applications, like feedback-based recommender systems, interactive material modeling, and personalized medicine. Normally, in such systems, the expected user's behavior is that a user provides truthful feedback. This means that when a user clicks the like button, they actually prefer the item. But some users may exhibit a different behavior. They may learn a model of the system, and they start providing feedback which is not necessarily truthful. This means that when a user clicks the like button, as we said before, they maybe not like the entire item. So for a song, maybe they only like the genre. We now need a little definition which will be crucial for the understanding of our research. This is user steering. We say that if a user is interacting with an AI and they learn a model of such AI and start providing untruthful feedback with a strategy aimed at reaching their target earlier, we say that such users are trying to steer the system towards their goals. Why should we study this behavior? We study this behavior because steering users can reach their target with fewer interactions, but also because they leak important information about their goal. For further information about this, please see the mentioned paper. How can we study this scenario? We designed a simple collaborative optimization task where we sample a one-dimensional function which needs to be optimized. We chose a one-dimensional function because it's easy for the user to understand and is flexible to be adapted for further studies. The rules are that the AI cannot see the function, so it tries to find the maximum by asking the users the height of some query point x. On the contrary, the user can see the function and provides some y values for each x point that the AI queries. However, notice that the user y may be different from the actual function value. We implemented this as a web application where the AI is a Bayesian optimization that uses a Gaussian kernel, and the acquisition function is an upper confidence bound. You can see here the user interface of the application. The light blue on the background is the confidence bound of the Gaussian process, and the dashed line in blue is the mean of the Gaussian process. The black line is the true function, while the yellow line, the vertical one, is the AI query point for which it's asking a feedback from the user. The red line is the cursor that the user uses, so they can move it up and down to provide their feedback. The setting of the study is as follows. The user started by reading some task instructions. Then we let them to familiarize with the user interface and practice some of the task mechanics. Then the users run the actual study. We begin with an optimization with 10 iterations, which is followed by one with 5 iterations, which is slightly harder. Then the users complete the questionnaire on their background and also of their behavior during the task. You can see here a demo of the application. The user moved the cursor, the red line, to provide their feedback. And in the beginning, they are truthful. They provide the correct value of the functions. But then they learn that maybe providing untruthful feedback may be beneficial, and they start steering, and so you can see how in few iterations they reach the maximum of the function. We compared the user that steered the system with a baseline, so a normal Bayesian optimization with no steering, in the same setting. What we could discover is that steering users perform statistically significantly better than the baseline, and also their score increased faster than the baseline. Our conclusion about this study are that users strategically steered the interactive system to control them. They also, in this behavior, can achieve better performance. One additional thing is that next-generation intelligent systems could exploit such steering behavior to further improve their performance. However, exploiting such steering behavior requires user model capable of anticipating this. So, what did we discuss today? We shown that users are not always truthful in their feedback, and that they steer the AI towards their goal to reach the objective in fewer iterations. Such users also may leak further information having this steering behavior. Thank you for your attention. Please check our website for more information and a demo of the system. Thank you.